Hello everyone and welcome back to another reaction video. Today we are moving away from history a bit and watching a science video. Today we will be watching Black Holes Explained From Birth to Death by Kurzgesagt, which is an excellent channel. I recommend you check it out. But yeah, without further ado, let's get into it.
Black holes are one of the strangest things in existence. They don't seem to make any sense at all. Where do they come from? And what happens if you fall into one?
Good questions.
Stars are incredibly massive collections of mostly hydrogen atoms that collapse from enormous gas clouds under their own gravity. In their core, nuclear fusion crushes hydrogen atoms into helium, releasing a tremendous amount of energy. This energy, in the form of radiation, pushes against gravity, maintaining a delicate balance between the two forces. As long as there is fusion in the core, a star remains stable enough. But for stars with way more mass than our own Sun, the heat and pressure at the core allow them to fuse heavier elements until they reach iron. Unlike all the elements that went before, the fusion process that creates iron doesn't generate any energy. Iron builds up at the center of the star until it reaches a critical amount, and the balance between radiation and gravity is suddenly broken. The core collapses. Within a fraction of a second, the star implodes, moving at about a quarter of the speed of light, feeding even more mass into the core. It's at this very moment that all the heavier elements in the universe are created as the star dies in a supernova explosion. This produces either a neutron star, or if the star is massive enough, the entire mass of the core collapses into a black hole.
Yeah, the amount of forces involved in collapsing a star like this is mind-boggling. One would like to observe such an event in action. But yeah, I don't think we'll be doing that anytime soon.
If you looked at a black hole, what you'd really be seeing is the event horizon.
Right.
Anything that crosses the event horizon needs to be traveling faster than the speed of light to escape. In other words, it's impossible.
Oh yeah?
So
Watch
we
me.
just see a black sphere reflecting nothing. But if the event horizon is the black part, what is the whole part of the black hole? The singularity. We're not sure what it is exactly. A singularity may be infinitely dense, meaning all its mass is concentrated into a single point in space with no surface or volume, or something completely different. Right now, we just don't know. It's like a dividing by zero error. By the way, black holes do not suck things up like a vacuum cleaner. If we were to swap the Sun for an equally massive black hole, nothing much would change for Earth.
Right, because the black hole would still be the gravitational center that makes all the planets spin. And it would maintain the orbit. But yeah, that's the common misconception that the black holes just simply suck things in and grows larger and larger. And it's not quite that simple.
Except that we would freeze to death, of course. What would...
Okay, that's a pretty big change. I don't know about you guys, but I prefer a planet that is warmed by the sun and not frozen to death.
happen to you if you fell into a black hole? The experience of time is different around black holes. From the outside, you seem to slow down as you approach the event horizon, so time passes slower for you. At some point, you would appear to freeze in time, slowly turn red, and disappear. While from your perspective, you can watch the rest of the universe in fast forward, kind of like seeing into the future. Right now,
Just think about it. Just think about it. That's how powerful a black hole is. Like, it literally changes the perception of time itself. Wow.
we don't know what happens next, but we think it could be one of two things. One, you die a quick death. A black hole curves space so much that once you cross the event horizon, there is only one possible direction. You can take this literally. Inside the event horizon, you can only go in one direction. It's like being in a really tight alley that closes behind you after each step. The mass of a black hole is so concentrated, at some point even tiny distances of a few centimeters would mean that gravity acts with millions of times more force on different parts of your body. Your cells get torn apart as your body stretches more and more until you're a hot stream of plasma, one atom wide. Two, you die a very quick death. Very soon after you cross the event horizon, you would hit a firewall and be terminated in an instant. Neither of these options are particularly pleasant.
You
How
don't
soon
say.
you would die depends on the mass of the black hole. A smaller black hole would kill you before you even entered its event horizon, while you probably could travel inside a supermassive black hole for quite a while. As a rule of thumb, the further away from the singularity you are, the longer you live. Black holes come in different sizes. There are
That's a
stellar
small
mass black holes with a few times the mass of the Sun and the diameter of an asteroid. And then there are these supermassive black holes, which are found at the heart of every galaxy and have been feeding for billions of years. Currently, the largest supermassive black hole known is S50014+81.
You gotta love these creative names, eh? I understand that there are so many objects in the universe, you cannot give everything a unique name, but I always find these number names they give stellar objects be quite, how shall I say it, boring.
40 billion times the mass of our Sun. It is 236.7 billion kilometers in diameter, which is 47 times the distance from the Sun to Pluto. As powerful as black holes are, they will eventually evaporate through a process called Hawking radiation. To understand how this works,
Hawking radiation, named of course after Stephen Hawking, a very famous physicist, one of the most brilliant men that have ever lived, I would wager.
we have to look at empty space. Empty space is not really empty, but filled with virtual particles popping into existence and annihilating each other again. When this happens right on the edge of a black hole, one of the virtual particles will be drawn into the black hole and the other will escape and become a real particle. So the black hole is losing energy. This happens incredibly slowly at first and gets faster as the black hole becomes smaller. When it arrives at the mass of a large asteroid, it's radiating at room temperature. When it has the mass of a mountain, it radiates with about the heat of our Sun, and in the last second of its life, the black hole radiates away with the energy of billions of nuclear bombs in a huge explosion. But this process is incredibly slow. The biggest black holes we know might take up to a googol years to evaporate.
That's a lot of
This
years.
is so long that when the last black hole radiates away, nobody will be around to witness it. The universe will have become uninhabitable long before then.
And that's one of the more terrifying things about the universe. It's that the universe is dying very slowly, but assuredly. The universe is stretching and stretching due to a process. Can't find a name for it in my head right now, but it involves dark matter and dark energy and all that good stuff. But yeah, eventually the universe will just be a big empty nothingness. So yeah, that's a terrifying prospect on a philosophical level or existential level, perhaps. Even though nobody will be around to witness the death of the universe.
This is not the end of our story. There are loads more interesting ideas about black holes. We'll explore them in part 2.
It's amazing how much we know about black holes and the universe itself, and there's still so much we have no clue about. And this is why we really should be funding space exploration and stuff like that much more, rather than spending our funds on stupid stuff like, wars. But I digress. Anyways, I think that was the end of the video. We'll be continuing to look at black holes in the future and more Kurzgesagt. Oh well, forgot the name. Anyways, we will be looking at more videos from this channel. And yeah, hope you like this reaction video, and I'll see you next time.